So the second factor that influences the way that hemoglobin behaves is called the Bohr effect. So this is the influence of pH on the behavior of hemoglobin. And what we see is that when we have an increase in pH or a lower pH rather, and an increase in acid, we see that oxygen unloads more easily, okay? What are some instances where we see increased acid? Lactic acid, for example. Increase in exercise, right? Which is another thing that increases metabolic activity. So increase in acid or lower pH increases the unloading of oxygen and shifts our curve to the right and makes oxygen and hemoglobin really unattracted to each other so that oxygen can dissociate very easily. That's called the Bohr effect. So if we produce more acid or decrease our pH in tissues, we shift this curve to the right, and this allows oxygen to unload more easily. Alrighty? Okay, so let's illustrate that here again. Okay, so we're describing this as the Bohr effect. And we talked about this equation, right? So hemoglobin, deoxyhemoglobin plus oxygen can become oxyhemoglobin. And then we've also got some protons released. Okay, let's just label this out. Now, given the law of mass action that we spoke about, so the law of mass action dictated to us that if we have more products, we drive the reaction towards reactants, and if we've got more reactants, we drive the reaction towards products. So if we have more acid, which is one of our products, and remember, more acid is lower pH. So high acid, low pH, low acid, high pH, okay? So this is a low pH. Then this drives the reaction to the left, right? And another way that we can think about this is that if we've got more acid or more protons, then oxygen is going to dissociate from hemoglobin more readily, right? As we drive this reaction to the left, oxygen kicks off of that hemoglobin and we end up with deoxyhemoglobin, right? So oxygen dissociates easily, okay? And what's another way we can think about that in terms of our shift, right or left? Based upon what we just drew on our previous slide. To the right, right? So if oxygen doesn't want to be on hemoglobin, that's shifting our curve to the right, okay? So another way we can think about that is a right shift. All right, so let's draw this out here, kind of make more sense. So we've got our partial pressure of oxygen. We've got our percent hemoglobin, oxygen saturation. Okay. We've got our standard sigmoid-shaped curve. Then we've got a shift to the left and a shift to the right. Okay, so what we're saying here is that at decreased pH or more acid, remember protons are acidic, so this is what I'm calling acid, these protons. This causes a right shift And if we're thinking about the overall picture, like I mentioned earlier, this is again, increase in metabolic activity. So think about things like lactic acid production, right? Lactic acid, which is going to drive this curve to the right by, which is going to shift the curve to the right by driving this reaction to the left, okay? Think about lactic acid production, which is an increase in metabolic activity. Okay, so if you're really understanding why the curve shifts to the right, you really won't have to memorize each of these points so much as understanding why acid does what it does because of the bigger picture of that metabolic activity increase. So when you shift the curve to the left, this is caused by an increase in pH. So if the pH becomes more alkaline, right, or a decrease in the acid production, and that causes a left shift.